Spectra. When light emitted or absorbed by a substance is dispersed, split, into its component wavelengths by means of a prism or diffraction grating, a series of bright or dark lines or bands is obtained. This arrangement of radiations according to wavelength, or frequency, is called a spectrum, and the study of such patterns is known as spectroscopy. In simple words, spectrum is the graphical or visual representation of light separated into different wavelengths. Types of spectra. Spectra are mainly of two types. Emission spectra. Absorption spectra. Emission spectra. The spectrum which arises due to the emission of light from a luminous body is known as an emission spectrum. Absorption spectra. The spectrum which arises due to the absorption of certain wavelengths of light by a substance, when white or continuous light is passed through it, is known as an absorption spectrum. When atoms, molecules, or bulk matter are excited, by heating, electric discharge, etc., they emit radiations of characteristic wavelengths, and the study of these radiations gives the emission spectrum. When a substance is placed in the path of continuous radiation, it absorbs certain specific wavelengths of the radiation. The absorbed wavelengths disappear from the observed spectrum and appear as dark lines or bands on the background of the continuous spectrum. Emission spectra are of two types: A. Continuous emission spectrum and B. Discontinuous emission spectrum. Absorption spectra may be line absorption or continuous absorption. Examples: O continuous right-pointing arrow sun, hot filament. O line right-pointing arrow sodium lamp, hydrogen spectrum. O band right-pointing arrow CO, N gases. Examples: O solar spectrum, Fraunhofer lines. O sodium vapor plus white light. O colored glass plates. Emission spectra are of two types. Continuous emission spectrum. Discontinuous emission spectrum. Continuous emission spectrum contains a wide range of wavelengths without gaps. The wavelengths are inseparable. Produced when a solid, liquid, or dense gas is heated to a high temperature. The emitted radiation covers a continuous range of colors from red to violet. The intensity distribution of such a spectrum is non-uniform and depends on the temperature. It obeys Wien's displacement law, lambda max proportional 1, T. Sources: lamp filaments, hot iron, tungsten filament of an electric bulb, the sun, etc. Discontinuous emission spectrum. This type consists of separate, discrete wavelengths and can be further classified into I. Line spectrum. Contains sharp, bright, or dark lines at definite wavelengths. Each line corresponds to the transition of an electron between two energy levels of an atom. The nature of the spectrum depends on the element producing it. Each element produces a unique line spectrum, like a fingerprint. Example: hydrogen spectrum, sodium, Na, spectrum, mercury vapor lamp, metallic arc, sodium discharge lamp, etc. O. E. Band spectrum. Appears as a group of closely spaced lines, bands. Produced when the radiating substance is in the molecular state. Bands are arranged in a regular pattern. Within each band, intensity gradually changes. Sources: gases like CO, N, and other molecules in discharge tubes. Absorption spectra. Line absorption spectrum. Continuous absorption spectrum. Absorption spectra. Absorption spectra may be line absorption or continuous absorption. A. Line absorption spectrum, formed when atoms absorb light of certain definite wavelengths. Example: passing white light through a sodium vapor right-pointing arrow, dark lines appear in the yellow region corresponding to the sodium emission lines. B. Continuous absorption spectrum, formed when a solid or filter absorbs a continuous range of wavelengths. Example: a green glass plate absorbs all wavelengths of white light except the green part, producing a continuous absorption spectrum. Thank you for watching this video. For more video, please subscribe this channel.